Azul DevRel Espresso, brewed for Java minds.
Welcome to my session about slimming down Docker images to Heavy for the Chevy. My name is Gerrit Grunwald. I'm working for Azul as a developer advocate, and today I would like to talk about how you can slim down Docker images to make them smaller using jlink, which is a tool to do exactly this, to create custom runtime images that are tailored to your application. So to make this work, I created a little example app, which is not really something special. So it's a name service. It's a Spring Boot application. You can find it when you scan the QR code that you see here. It just has one REST endpoint and it returns random names for girls and boys. So it's not really very special. The big question that always arises when you talk about Java in the cloud is Java really heavy, or is it too heavy? Well, to get a better picture, we have to take a look at the different possibilities that we have here. So first of all, there is the so-called JDK, the Java Development Kit. And this contains around 70 modules because we have, since JDK 9, we have a modular JDK. So it has a lot of different modules for all kinds of things. And the size of the JDK, for example, is around 338 megabytes with all these 70 modules in there. So, and then if we then take, for example, an Ubuntu base image and JDK 1709 for this example, then we have a Docker file that will look like this. So you see, I just grab the JDK and the Docker image, and then I run my app in this, the name service jar here, and put it in there, and that's my container. So now if I take a look at the size of the container, there is a tool called dive. I use that, and if you check the container size, then we will figure out that this container is 638 megabytes. That's a lot. I mean, this is just a tiny, tiny service that has just one REST endpoint, doesn't really do a lot. But the container that we need to deploy that has a size of 638 megabytes. Well, that's quite big. So I totally agree that people don't like the size of this, but luckily us, there are different possibilities. The next thing that we can take a look at is the Java runtime environment, right? So this is a stripped down version of the JDK that only contains the classes that you need to run your application. So you don't need Javadoc in there, you don't need the compiler and all that, right? So the Java C compiler, because this is already done. So we just need the stuff to run, the class libraries and these things, to run our application. But if we take a look at this, then we figure out, that's smaller. It's just 142 megabytes in size, and it has 50 modules, right? Not 70. That's less, but still not really small. So if we again take Ubuntu with the JRE 1709 to compare it to the JDK version, then our Docker file will look like this. And as you can see, I just really exchanged the JDK by the JRE, create my Docker image by copy my file in there and the JRE, and then we end up with the size of 290 megabytes. Well, this is already not too bad compared to 638, but still, to be honest, 290 megabytes to just have one REST endpoint in a very tiny service, still quite big. So let's see if we can strip it down further. So the question is, do we have alternatives here? And yes, we have. So there is, first of all, the JEP 220, and this is modular runtime images. So the idea behind that is that you create a modular runtime image that only contains the app and the platform-specific modules. So that means really the bare minimum that you need to run your application. Instead of providing with the JRE everything that is needed to run a Java application, we now create a Java runtime image that only contains the modules that our application needs to run, right? And you can imagine you don't need all the modules in the runtime environment. You need just specific ones, so you can really slim down the size. The question is how to create that. And again, we are lucky because there's another JEP, which is JEP 282, and that's the so-called jlink tool. This is part of the JDK since JDK 9, so you can use it. So it's provided by all distributions. And the jlink tool is made to assemble and optimize a set of modules and their dependencies in a custom runtime image. Perfect. If you scan the QR code, you will find a link that gives you more information here. The idea is just take all the modules and you provide the list of modules and then create a runtime image out of these modules, right? So therefore, we have some command line parameters that we can see here. I don't want to go through all this stuff. The most important one is the add modules, and that contains the list of all the modules that you need. Well, that's cool, but the question is, how do I get the modules? So how do I know which modules are used by my applications? Well, there's another tool, of course, and it's also part of the JDK. It's called jdeps. And the jdeps tool shows package level or class level dependencies of a Java class file. You can scan the QR code to get more information as usual here. And the idea is you take a jar file, you run the jdeps tool against the jar file, and it will spit out all the modules that this jar file uses, which is quite convenient, right? So it has command line parameters, as we saw before. So, and it has again a class path parameter. So you can point it to a folder, like in this case libs, that contains additional jar files, and then the app jar that contains the application itself. And if you run that, it will spit out something like this. This is just an example. It gives you all the modules that are used by this application or by this jar file. And then you can take this list and use it in the jlink tool in the add modules section, right? You just copy it over and then use it there. And then you can create a runtime image that only contains these modules. Quite cool. There's another way where we can even slim it down further. Instead of using Ubuntu, we just use Alpine Linux, which is from nature, it's smaller because it uses the Musel library instead of libc. And if we use this one and we take the Docker image to do that, then we unpack the Spring Boot fat jar that we created, for example, in the build unpacked folder here. Then we run the jdeps tool against this jar file, right? And therefore it would look like this, for example, right? So we have the class path with the build unpacked. We pointed to the lib folder inside, which contains the other jar files. And then we just pointed also to all jar file of the application itself. So then it will spit out all the modules that my application needs to run. And the result will look like this. So these are the modules that we need. It's around 14. So remember, the JRE contains 50 modules. My application only needs 14 of these 50 modules to run. So why using a JRE, right, if I only need 14? So now I copy this list of modules into my Docker file. And then it would look like this. So we have the Docker file where I just, first of all, add the JDK. I need that to extract the modules that I need to run it later on. And then I run the jlink tool with the parameters. And you see, I copied in the add modules, I copied the list of modules that I got from the jdeps tool and create a Java runtime out of it. I've just put it here in the jlink -runtime folder. And then I take the Alpine base image and copy my JRE inside of it and also the jar file of the application. So now if I again inspect the Docker image that I created here with the dive tool, then I will find out, wow, this is now only 96 megabytes, which is really nice, right? Compare it to the 290 before or 638 in the beginning. So if we compare these images in size, then we will see that the JDK, which has 70 modules with the Ubuntu version here, was 638 megabytes, quite big. If we use the JRE, still on Ubuntu, then we could reduce the size of the image of the container by 54% to 290 megabytes. And we'll still have 50 modules in there that we don't really need. We saw that with the jdeps tool. Now, if I compare that to the jlink version that I created, we can reduce further 66% to 96 megabytes. It only contains 14 modules. Compare it to the JDK version, it's a reduction of 85% in size. Just let that sink in, right? So you can really create relatively small Docker images using the jlink tool with a custom runtime image tailored to your application. So you should really think about using jlink instead of using a JRE or a JDK. It can save you cost and it can save you deployment time, that's for sure. And with this, I say thanks for listening and see you next time.